Okay, this is our new duplex heat timer electronic mixing valve installation at Houston Methodist West in the East Tower, Patient Tower. We come in and look at this, our major components. We have our two electronic three-way mixing valves. On the right side, coming into the valve, is the cold water supply. The bottom connection is the hot water supply coming from the domestic hot water heaters. And the left side of the valve is the mixed water temperature going out to the patient floor. We have the little power distribution panel on the right side where we brought in power and we're distributing it to the main control panel and down to the hot water return pump. And then we have our main controller. So to go into a little more detail, let's take a look. We've got two hot water return lines coming back from the patient floor. Each one of those has a manual balancing valve on it. Allows us to balance each one of those return lines and somewhat restrict the flow coming back to the system. That line comes down and goes into the inlet of our hot water return pump. This is a very special pump. This is the Grumpus Magna 3. We call it an intelligent pump. This hot water return pump has the motor has an integral variable frequency drive as well as onboard PID controls. We have this set up for constant return temperature. The pump actually has a temperature sensor on the inlet. As you can see, we've got a set point of 110 degrees. We're coming back at 111 degrees. So we're maintaining very tight control there. On the discharge side of this pump, we actually split the return load between the mixing valve and going back to the domestic hot water heaters through a T and a series of check valves. This is the line going actually back to the domestic water heaters. We've got that somewhat balanced through that ball valve. And then back, you'll see there's a T here and a check valve, and we discharge directly into the cold water supply to the electronic mixing valve. This sensor right here, sensor number 1, we're actually monitoring that mixed temperature between cold water and hot water return, and we're using that for control. We go into the cold water supply on the electronic mixing valve. Then if we come back and take a look on the bottom, this is the hot water supply coming from the domestic hot water heaters. You'll notice that we have the ball valves significantly choked down. Actually, I have one of them completely off and only have the one on the back open. The reason for that is that we determined after we commissioned this that these 2-inch valves are substantially larger than what's required for the demand in the patient tower. When we do the West Tower, we'll probably reduce those valves to 1 inch. But this has allowed us to balance it, and it's providing very good control. But you'll see we're going into the bottom of the mixing valves. And then coming out on the left-hand side of the mixing valve is where we actually have the mixed temperature, the tempered water. And they tee together, go around to the back of the station, and then tee up and connect in directly into the patient floor. We've got our main system temperature sensor is looking at that mixed water temperature, and that's one of our primary elements of control. We also have a temperature sensor down looking at the domestic hot water coming from the plant. From a control standpoint, our little power distribution panel here is nothing more than we actually have 120 volt coming in, and then we have a 24 volt transformer to power the second valve. The main controller only has enough 24 volt capacity for one valve. So out of this box, we're powering one of the valves with 24 volt. We're powering the hot water return pump with 110 volt, and we're powering the main controller with 110 volt, 120 volt. So when we look at the main controller and you look at the display, you'll notice there are 3 different temperatures. The 2 small temperatures at the top right, temperature number 1 is our cold water sensor, and you'll notice that varies due to the mixture of cold water and return water. As we get demands in the system, that temperature drops. And the controller actually uses that to what we anticipate load changes. It gives us what we call feed forward demand. Allows the controller to respond to load changes even before we see a drop or an increase in the leaving mixed water temperature. The temperature below that, number 2, the 144 degrees, is the domestic hot water coming from the plant. And then the large system temperature is the mixed water temperature going out to the patient floor. Below that is our target temperature. That's our set point of 120 degrees. And then below that is the mod out. That's the modulating output to each one of the electronic control valves. You'll see the little actuator signal green LED pulse. Anytime that pulses, it's changing the output to the valve, either increasing or decreasing. You can sit here and can watch. We've got a relatively low demand right now. The valves are only actuated at 8% going out to each valve. The temperatures 1 and 2, especially 1, it's very stable. When it increases, it means the demand is falling off. When it decreases, it means the demand is increased. So you'll notice it's falling off now, and the output is increasing. We're up to about 12%, 13%, and it'll continue to increase until we make set point. But you'll notice that the variance around set point is only about 2 to 3 degrees. And this is on very low end, which is the more difficult range of control as far as maintaining set point. When the demand actually puts us up in the 40 to 50% range, we even get greater accuracy in the control. This is pretty representative of the demand on this patient floor throughout the day. We occasionally see greater demands that take us into the 40 to 50% range. But overall, there's not any large hot water users on the floor, primarily hand washing. We're up to 15% on the valves. If we take a look at the valves, you can watch and see the actual valve stem reacting to changes from the output on the controller, slightly moving up or slightly moving down. Provides a very stable mixed water temperature to the patient floor. As you can see, we're maintaining right around that 12 to 15% range. Temperature fluctuating between 118 and 122. Here's a little bit higher demand. We're up to about 20% on the valve. But you can see it's a very stable and controlled response to load swings. almost all the way off on that valve, but as the demand came back up, again, primarily in reaction to the change in the cold water temperature, as you're seeing now, with a pretty good demand, reacting quite quickly and minimizing that variance from set point.